1945, a beach in the Philippine Islands. An American Sherman tank crew spotted a Japanese soldier running toward them with what looked like a bamboo pole. They dismissed him as desperate, except this was not a pole. It was a bomb on a stick, a 3-cone-shaped warhead with a contact fuse that would detonate on impact. The soldier was the delivery system. He thrust the weapon against the hull. The shaped charge penetrated the armor, killing the crew inside. The explosion killed him instantly. This was the Type 4 Lunge Mine, WWII in Japanese, Japan's answer to American armor superiority through weaponized human sacrifice. To understand why Japan developed the Lunge Mine, you have to understand how completely American armor dominated Pacific Island combat by 1944. Between 1942 and 1945, American factories produced 49,234 M4 Sherman medium tanks. Thousands reached the Pacific Theater. The Sherman's 75mm gun could destroy concrete pillboxes and reinforced bunkers. Its armor proved nearly impervious to Japanese small arms. Japanese soldiers with rifles and grenades could not stop 30-ton armored vehicles. On Saipan, Iwo Jima, and Okinawa, American tanks systematically destroyed Japanese defensive positions. Records show consistent patterns. Infantry attacks without armor stalled with heavy casualties, while tank infantry operations achieved objectives. Japan faced this from severe disadvantage. Between 1941 and 1945, Japan manufactured approximately 6,300 tanks total. Most remained in Manchuria or the home islands. Few reached Pacific garrisons. Even Japan's Type 97 Chiha tank, with 57 mm gun and thin armor, lost consistently against Shermans. Japanese defenders needed to stop American tanks but lacked the weapons to do it. Japanese forces needed anti-tank weapons, but conventional solutions required resources Japan no longer possessed. Effective anti-tank defense meant towed guns, tank destroyers, or minefields. All required industrial capacity and logistics Japan could not sustain. American submarines had severed supply lines. The weapons Japan could produce proved inadequate. The Type 97 20mm anti-tank rifle could not penetrate Sherman frontal armor. Close assault weapons like magnetic mines and satchel charges required suicidal approaches. Many died trying. Japan needed something requiring minimal industrial capacity, minimal training, and maximum availability. Something that turned Japan's one inexhaustible resource into an effective counter to American armor. The solution emerged from Japanese Army technical bureaus in late 1944. Military engineers turned to shaped charge technology. A cone-shaped cavity could focus explosive energy into a high-velocity jet capable of penetrating thick armor. German Panzerfaust and American Bazooka used the same physics. Japan eliminated the launcher. By September 1944, the Army finalized the Type 4 Lunge Mine design. Production authorization came in October. First deliveries occurred by December. The Army Technical Bureau oversaw production across multiple facilities. Kokura Arsenal in Kyushu manufactured substantial quantities. Post-war assessments indicate Japan produced between 30,000 and 40,000 lunge mines between late 1944 and August 1945. Production efficiency was the weapon's achievement. Each required minimal steel, 1 kilogram of explosive simple detonators, and a wooden pole. Assembly could be taught in hours. The Philippines, Okinawa, Iwo Jima, and the home islands all received shipments. The Lunge Mine fit Japan's special attack doctrine alongside kamikaze aircraft and Kaiten torpedoes. Employment meant death. The technical challenge: deliver a shaped charge to tank armor using a human operator. The Type 4 consisted of 3 components. A wooden pole, 1 to 1.5 meters long, served as the delivery shaft. A conical metal housing at the forward end contained the shaped charge warhead. A simple arming mechanism at the rear allowed the operator to transport and employ the weapon. The warhead used a 3-cone nested configuration. 3 progressively smaller metal cones channeled explosive force into a high-velocity jet. Upon detonation, the explosive collapsed these cones inward, generating a jet of superplastic metal traveling at approximately 8,000 meters per second. Japanese engineers filled the warhead with approximately 3 kilograms of Type 97 explosive, a TNT-based composition. The wooden pole held the warhead 1 meter from the operator's hands, allowing the shaped charge jet to form before striking armor. At optimal standoff, the Type 4 could penetrate 150 mm of armor plate. Sherman armor ranged from 38 to 75 mm. The Lunge Mine could defeat it from any angle. The fusing mechanism used a simple contact fuse. Impact triggered the detonator. No complex timing, no electronics. Training lasted 4 to 8 hours. Soldiers learned to approach under cover, sprint the final distance, and thrust forward. They understood the outcome. The German Panzerfaust allowed operators to retreat. The Lunge Mine sacrificed survival for production simplicity. Manufacturing reflected wartime industrial collapse. Lunge mines required only basic metalworking. Kokura Arsenal and smaller facilities produced weapons using simplified tooling. Workers formed cones from sheet steel and packed explosive around them. Wooden poles came from local bamboo or hardwood. Fuse quality varied significantly. Distribution followed army supply channels. The 14th Area Army defending Luzon stockpiled thousands from January 1945. Units on Leyte employed them in October 1944. The 32nd Army on Okinawa received thousands before the April invasion. Japanese engineers positioned weapons near likely tank approach routes. Iwo Jima defenders possessed them in February 1945. Home islands accumulated massive reserves for Operation Katsugo, the defense against invasion. Training varied by unit. Early weapons went to veteran formations. By mid-1945, replacement, troops arrived with minimal preparation. American intelligence identified the weapon by late 1944. Technical reports circulated warning tank crews of the threat. Despite production of 30,000 to 40,000 units and widespread distribution, documented records of specific attacks remained sparse. American reports rarely distinguished lunge mines from other close assault methods. Japanese records were destroyed. Successful attacks left minimal evidence. Destroyed tanks showed penetration holes, but identifying the weapon proved difficult. Tank crews filing reports noted tanks destroyed by close assault, but could not specify whether lunge mines, magnetic mines, or satchel charges were used. Pacific Island combat across difficult terrain complicated attribution further. Japanese unit records were destroyed before surrender. The weapon's effectiveness may have been substantially psychological rather than material. Creating fear and forcing tactical changes did not require high kill rates. If success cannot be counted in confirmed kills, measure it in tactics disrupted and psychological burden imposed. American forces understood the threat because they changed how they fought. Tank doctrine underwent revision. Infantry-tank coordination became mandatory. Every tank required infantry screening to engage enemy soldiers before close assault range. Standoff distance requirements increased. Doctrine called for maintaining maximum distance from Japanese positions. Combined arms emphasis intensified. Artillery, bombing, and flamethrowers reduced positions before tanks approached. The psychological burden proved substantial. Pacific crews faced enemies who accepted death to deliver attacks. Tank commanders reported constant vigilance, heightened anxiety, and reluctance to advance without overwhelming support. On Okinawa, the 713th Tank Battalion and 1st Marine Tank Battalion reported multiple Shermans destroyed by infantry attack. Precise attribution remains impossible. Kamikaze attacks prompted massive fleet defense expansion. Lunge mines forced systematic tactical response. Japan's calculation traded lives for time and casualties. The strategy failed. American forces accepted higher casualties as victory's price. Special attack weapons prolonged campaigns but could not prevent outcomes. American intelligence classified lunge mines as serious threat requiring countermeasures, but not strategic concern. The weapon could kill individual tanks. It could not stop armor-supported offensives. Physical examples survive today. The Imperial War Museum in London, the National Museum of the Pacific War in Texas, and the U.S. Army Ordnance Museum maintain specimens. These reveal the crude but functional engineering of late-war Japanese manufacture. American technical intelligence evaluated captured weapons extensively. Reports analyzed construction and tactics. Soviet post-war development emphasized man-portable anti-tank systems, culminating in RPG grenades. Modern infantry. Weapons universally incorporate standoff capability. No military after 1945 adopted suicide delivery systems. The lunge mine represented an evolutionary dead end. Insurgent forces occasionally employed similar concepts. IEDs using shaped charges in Iraq and Afghanistan traced lineage to World War II technology, but used remote detonation. The strategic lesson proved enduring. Desperation produces innovation, but innovation from weakness rarely overcomes material superiority. Japan manufactured tens of thousands because it could not manufacture conventional weapons. American armor doctrine absorbed lasting lessons. Tank infantry coordination became permanent doctrine. The Lunge Mine forced American troops to confront an enemy willing to die. This shaped perceptions and influenced planning for Home Island's invasion. Casualty estimates assumed widespread suicide weapons. These projections contributed to the decision to employ atomic weapons. 1945, a soldier running at a tank with a pole. Between late 1944 and August 1945, Japan produced 30,000 to 40,000 of these weapons. Success cannot be measured in kills, but in tactics disrupted and uncertainty injected into every engagement. That was Japanese desperation. That was the Type 4 Lunge Mine, and that was how Japan turned soldiers into anti-tank weapons.